Hi, welcome to the intro step lecture series. And for this video, we are going to do the final exam review. And this is the final exam review part 1 here. Okay, let's take a look at what type of the problems we are going to have over the final exams here. Let's take a look here. All right, so let's go ahead and start here. All right, so the first things here, they say a survey of autos parking in the student parking lot. And let me get my color pens. All right, so in the student parking lot and the staffing parking lot, inside the parking garage in a large university. All right, so what is the probability your staff professor driving American car? Okay, your staff professor driving American car. So that means the first, right? So you are looking for the staffs here. So then under the staff, total how many staffs, right? Then you're driving the American car. So take a look here. So if you add all this together, what you go to get here, you get 160, like I think this is 164, right? Okay, so you total have 164 staff. So given you see a staff drove out of the garage, what is American car is 105, right? So the probability here will just be what is 105 over 164, right? So it's given this is a staff, and what is the chance this staff going to drive in the American car? So this one here is close to the point of what, 64 here. All right, so the answer will be ace here. All right, so now let's take a look at the second problem here. So for a highly left-skewed distribution, what is the relation between the values of the mean and the median? So we know the left skew and the right skew. So what is the differences here is it depends where is your type, where is your tail for the distributions, right? So like this one, I did not do too good of drawing here. So if your distribution have a long tail to the left, this is what we call the left tail, right? So skew to the left. If your distribution have a long tail to the right, this we call this a skew to the what? To the right. And this is we call it a skew to the left. Okay, so now in here, let's take a look. So like let's say we have a highly left skew distribution. That means I have a long tail to the left here. So we know the left value is what? So the smaller, so you got to allow the smaller values around here, right? And you know the average is you add everything together and divide by the number. So because you have those smaller number, so it's kind of going to average down, right? So that's probably your mean will be here. Okay, because it was dragging down by those small number. And then the medians has nothing to do with the extreme values, just right at the middle. So median probably will be here. Right, so that means we only care about half of the values below, half of the value above. I don't really care what are the values, right? So that's what is the median. So that's why I know if I have left skew, so what happens here? So the mean probably will be less than medians, right? So the mean probably will be less than medians here. So that's what is the part B here. By the way, this symbols here, the mean is not exactly equal to the median. Here, I should say it's a mean is medians here. Right, so that means the mean is very close, not exactly, not like 3 equal to 3. So that means mean is very close to the median. So the situation, it could happen if you have a symmetric distribution, right? So mean will be very close to the median. It's not to say equal, but they are pretty close, okay? All right, so let's take a look at the number 3 here. Which of the following statement is false? All right, so okay, let's take a look here. So the first one, let's say, the correlation can be positive or negative or zero. Correct? Yes, this is a correct statement. And then the next one is that the correlation has no unit. Correct? Correct. We don't have like a 0.62 weight, like a pounds, those things, right? So correlation has no units. And then the next ones here, they say R 0.823 show less linearity than R negative 0.910. So you say, oh, AO3 is greater than negative 0.910. No, because AO3 is just to show you it's a positive correlation. And this negative is just to show you the relations here is go negatives, right? So the AO3 is go positive like this. And because this one here is 90910, we know it's a perfect linear would be -1. So this one's here. So with R equal to negative 0.910 has a stronger linearity than R equal to 0.803. Okay, so the positive and negative number doesn't matter, right? Because let's just show you they are positive correlated or negative correlated, right? Okay, so this is the truth here. Okay, then the part D is here, they say the stronger correlation means strong cause effect. Is this true? No, this is not true here. So this is one of the things when we discussed correlation coefficient. We said correlation coefficients, right? So they just show you the linearity, but it doesn't mean the cause effect here, right? So you shouldn't treat it like a cause effects here. So this is a very important concept. Okay, so then the next ones here, they said when the R close to 0 does not mean there is no association between two variables. This is a true statement? This is a true statement. Why? Because when the R close to 0, because R is the linear correlation coefficient, right? So if you have like a data pattern look like this, for example, see here, right? So like this way, see here, they go small, then like small, then they continue to go up and then go down. So for this ones here, the R's here probably very close to 0. But do they have association? Oh yes, they do have association. They have this curve associations, right? So that doesn't mean R close to 0, does not mean they don't have associations, right? So this is a very good problem to summarize the concept of the R's here. Okay, so now the problem number 4 is here. And let's say find what is the probability. So if they said Z is from negative 1.33 to Z0 is 0.8832. What is the value of Z0s here? Okay, so first we say when we do this type of the problems, if you graph it, it's always better, right? So here, this is the 0, this is a negative 1.33. Okay, so the first thing that I say from the negative 1.33 to Z0 is equal to the AA30. So I need to decide where is my Z0s, right? So let's say here, okay, so let's say here, this is my Z0. Okay, it's possible the Z0 is less than 0. Okay, so in here they say from the negative 1.33 to Z0. So let me say this area is equal to the 0.AA32. Is it possible? No, because we know the half of here, right? So this is the half. What is the half of here? Half is 0.5. And then you cannot have this small piece is 0.AA32. So I know Z0 cannot be on the what? Z0 cannot be on the left-hand side of the zeros, right? Okay, so now let's take a look. So that means my Z0s here has to be on where? Has to be in here, right? Z0. So then they say here, this one's here is a pointer AA32. So we know when we use the table or when you use the TI-84 calculator, they typically give us is the tail values here. So that means here I'm missing these tails, right? So if I can find out what is this tail, then I can use the inverse norm to get my numbers here. All right. So now um, let's take a look here. Let's go to the calculators here. All right, so let's go to the calculator here. Okay, so this is our calculator. All right, so now let's turn the calculator on. So the first thing here, we do the second distribution. We know the second normal CDF. So if you normal CDF, we want to let the pink area we just did, right? So it's negative 1.33. So here the upper bound is negative 1.33. So in here, you need to be careful when you use the TI-84 calculator to input negative, you have to use this signs, right? So this is 1.33. Then it's mu sigma, okay? So what do we get there? We get a pointer 0.091759, right? Okay, so this is a 0.09759. Okay, so now let's go back to my works. Okay, so now we just got here. This is a 0.09759, right? Okay, so now if you add this green and this pink probability, what do you have here? This one here, you have 0.974959, right? So this is the area from all the way from here to here, right? So this is the so this is the area from all here, right? So now I know I will be able to use the inverse norm to get my z zeros here, right? Okay, now let's go back to our calculators here. Okay, so now I'm going to do the inverse norm. So it's the second verse. Then it's the inverse norm here, right? So what is the area? Remember, we said when we use TI-84 calculator, the area is always to the left. So a while ago, we already added. So it's a 0.974959. Okay, and dun here. Then we will see what is, so it's a 0.959, right? So it's a 1.95926. Okay, so now let's go back to our worksheets here. Okay, so then we got from from here, so we said we use the inverse norm. And what do we have here? We have a 1.95. So we have a 1.95926. So which one is the closest ones here? So it's 1.96. So it's the C here. Okay. Let's take a look at the next ones here. Problem number 5 is here. So the problem number 5, they said, okay, which scatter plot has a possible calculator with number negative 0.083 here? All right, so the 0.083, so first things here, we notice that this is very, very close to what? Close to 0, and it's negative. So this one, so we know this one not going to work, right? Because this is a positive correlation. And then this one is negative, but it's very strong because if you put the lines here, right? So it's almost like they will fit into the line very well. They hugging the line very closely. So we know cannot be that small. So this one is not. This one also is negative. It's kind of the linear relation is less than this one, but still they have type of the linear relations, right? So this one's here probably will be have negative 0.4 something or negative 0.5 something. So the answer is A here. So for here, because this is the R. What is the R? R is linear, right? So like this is obviously is not linear. So that's why when you try to fit a lines here, probably your line going to go like this. So that's why I make R very, very close to zeros here. Okay, so the answer is A. Okay, now let's take a look at number 4 here. Number 6 here. So which of the following p-value give you the most significant evidence to support the alternative hypothesis is true? All right. So support. Okay. So this is just like we talked before. We need to write it out. Support alternative hypothesis true. Let me support. What's that mean? That means I'm going to reject H0. Right? Support the alternative. That means I'm going to reject H0. So what is the p-value? So we know the smaller the p-value, smaller p-value is what? Is the stronger evidence to reject H0, right? So I want to have a stronger evidence to support alternative. I want to have the smaller the p-values here. So if you compare all these numbers, which one is the smallest one? Is the A here, right? Okay. Now, number 7 here. Number 7 is that we have a sample 100 freshman students from SMU and 100 freshman students from UD. You would like to compare the SAT math score between these two universities. Which of the following graph will be the best graphs here? All right, so let's take a look here. So we definitely think, the scatter plot not going to be a good one, because scatter plot is like you want to find the correlations, kind of you want to see there any association or not. But those 100 students, they are different, right? So pie chart is not a good chart to do that, because pie chart typical we're dealing with categorical. Okay, so the segment bar chart is not a good one to compare, because this is mainly for the, this is mainly for the, for the categorical data. Also, gift graph is a kind of, if you just want to do the histogram, you want to compare, its own distributions, percentage point, you can use a gift chart. So if you want to compare, we know the box plot probably is the best ones here, because then you can have a box plot like here, right? So you can have like, this is the one university's SAT, this is another university's SAT. You can do like those comparisons here. All right, so the box plot. So the gift chart is the chart sometimes look like in here you have like this is the histograms, right? So this is the histogram, and then in here, this is kind of like you have like percentage lines here. Okay, number 8 here. What is the probability for the Z is between the negative 0.05 and Z is 2.33. So this ones here basically tell you graph it, right? So this is 0. So this is negative 0.5, and this is 2.33. So you want to find this probability. So we know what is we can use the TI-84 calculator with the normal CDF, right? Okay, let's go to the calculator and take a look. Okay, so this one should be an easy input one. So let's turn that on. So we do a second vars. Then it's a normal CDF here, right? So now the lower bound is negative 0.05. So you need to clear that out. Remember, negative, you need to use this negative sign. So it's a negative 0.5. Then the upper is what? Is 2.33. Then you do, okay, so let's see what what do we have here? We have a 6A156, okay? All right, okay, so now let's, okay, right now, let's go back to our exam review. So while ago, we calculator is 6 pointer, so this one here is a pointer 6A156. So what is the closest ones here? Is the B, right? So it's a pointer 6A16. Okay, let's take a look at number 10 here. Okay, number 10 here. What are the three major things when we look at the scatter plot? We look at the form, directions, and the strengths, right? So those are the three things we need to remember. So this is the one we look at the form, strengths, and the directions here. Okay, let's take a look at the number. Okay, number 11 here. Okay, number 11, which of the following mean in typing? So after the whole semester, we are practicing with the R. So typing is one very, very important command in R. That means you pass through the information so you can continue to do the other function. So what is the typing here? Is this one, right? It's percent greater than percent, right? Okay, now let's take a look at number 12 here. So the number 12, they ask you to say, use the data here, right? And for the contingents table, you want to have a contingents table like this. That means in here, this is your contingents tables, right? So you have a sex over here, you have a race groups on top. Which of the following will be the correct coding if we want to create a summary report? All right, so the first thing here, if you take a look, the percentage wise here, right? So you notice when you add them together, all right, so when you add them together, so you add all this A, it will be the 100%. So you know the percent is compared by using what? By using the total groups, right? So that's why I know I need to have some comments like is the sex plus race group, right? So here race group I think is GRP. Okay, so it's so you need to combine that. That means you add that, so the overall you want to have the 100%. So you use the overall population to calculate the percentage, right? So to calculate the percentage for each sales here, be careful here, right? So I know I have to have the plus, right? So I have to have the plus here. Then the next thing here, you said, should I have the, do I put the sex in the front or I put like the race GRP plus the sex on the back here? Okay, so the things here we need to be careful here, right? So here we know we need to use a plus, so I only have the D and the E to be my choices, right? So which ones here? So be careful here. The one you put in the front will be your first columns here. All right. So that's how did the contingency tables work. Okay, so now the answers here is these here. All right. Okay, so this is a part one. We did 12 problems here. And so let's take a break and we will come back to continue and finish this, this exam review. Okay, have a nice day and talk to you soon in our next review tapes here. Okay, bye-bye.